Welcome to Collapsed Latents, this week in AI, where we cut through the noise and bring you the 5 most groundbreaking AI papers you need to know. This week, we're diving deep into long context mastery, smarter training, tiny but mighty models, storytelling integrity, and intelligent graph reasoning. The future of AI isn't just about scale, it's about structure, coherence, and precision. Let's get into it. #1. LoGR, the first feed-forward 3D model that doesn't forget the world. Imagine driving through the Colosseum for minutes, capturing over 20,000 frames of winding corridors, shifting sunlight and towering arches, and reconstructing the entire space into a single, accurate 3D model in real time. No post-processing, no manual stitching, no geometric collapse. This isn't science fiction. It's LoGR, long-context geometric reconstruction with hybrid memory, a breakthrough from Google DeepMind and UC Berkeley that shatters two long-standing barriers, the context wall and the data wall. For years, 3D reconstruction models like Dust3R or Pi3 were capped at just a few dozen frames. Why? Because transformers scale quadratically with sequence length. 1,000 frames means a million attention interactions. Even if you could compute it, the model would suffer from scale drift, trajectory wobble, and geometric collapse, losing its grip on the world over time. LoGR's solution: a dual memory architecture that decouples 3 critical needs. Local precision, fine details like cracks in stone or texture on marble. Adjacent alignment, seamless stitching between consecutive chunks. Global consistency, maintaining scale, orientation, and spatial coherence across tens of thousands of frames. It splits the input video into overlapping chunks, 64 or 128 frames, and processes each with a bidirectional transformer. But here's the key. Instead of processing everything at once, it uses sliding window attention, SWA, a lossless mechanism that copies high-fidelity features from the previous chunk and aligns them directly. No compression, no information loss, just continuity. Then for global memory, it employs test-time training, TTT, a lightweight evolving neural memory bank that stores coarse geometry, scale, and motion dynamics. It's parametric but intentionally lossy, designed not for pixel-level detail, but for anchoring the world. It's like a compass that keeps the model from drifting. And the training: a curriculum schedule, start small, scale up gradually. The model learns to rely on TTT only after local features stabilize. It's not just training, it's learning to remember. The results are staggering. On KITTI, 74% lower trajectory error than prior models. On VBR, a 19,000 frame benchmark of Rome, 30.8% improvement. And it generalizes. Trained on 128 frames, it handles 19,000 at inference with no retraining. This isn't just better 3D modeling. It's real-time world reconstruction for self-driving cars, robots, and AR/VR. Feed-forward, scalable, and globally consistent. The first model to truly remember the world it's reconstructing. #2. ProRes, the secret to training deeper transformers without losing your mind. Now let's talk about training, because as transformers grow deeper, they become wildly unstable. Why? Because every layer updates simultaneously. Deep layers are trying to learn from noisy, chaotic inputs from shallow layers that haven't even stabilized yet. It's like asking a calculus student to solve a differential equation before they've mastered algebra. Enter progressive residual warm-up, ProRes, a simple but revolutionary method that rethinks how residual connections behave. Instead of turning on all layers at once, ProRes introduces a time and depth-aware scaling factor. Alpha LT equals min T/T times L1. So layer 1 finishes warming up at step T, layer 2 at 2T. Layer 3 at 3T. Deeper layers wait until the foundation is solid. The result: smoother activation norms, less noise, and 0 spike scores even at 120 layers. Vanilla transformers go haywire. ProRes stays calm, like a student who's been taught to build step by step. And the performance: on C4, 0.5 lower perplexity. On Lambda, plus 3% accuracy in long-range reasoning. On Hellaswag, plus 25%. Why? Because deeper layers don't inject noise early. They only contribute when they can make a meaningful difference. This isn't just better performance, it's better learning. ProRes teaches the model to learn in order, just like a human student. First the basics, then the advanced stuff. And it's lightweight, no extra parameters, no complex architecture. Just a scalar multiplier that evolves over time. ProRes isn't a fix. It's a philosophy. The best way to go deeper is to go slower, at least at first. #3. InternVL-U, the tiny model that beats giants. Meet InternVL-U, a 3.7 billion parameter model that outperforms models with over 14 billion parameters, including top closed-source systems. And it's not just smart, it's unified. Most AI models are specialists, one for understanding, one for generating, one for editing. But InternVL-U has one brain, two minds. It decouples reasoning from generation. A deep semantic network handles logic, context, causality. A high-fidelity visual engine handles texture, lighting, pixel-perfect output. And it doesn't just react, it plans. Using chain-of-thought reasoning, it thinks step by step. Identify emotion, right arrow, add bold title, right arrow, preserve structure, right arrow, place text with contrast. It's not just for memes. It solves Sudoku from images, draws accurate scientific diagrams, and edits text on license plates, without blurring the background or warping the logo. Why? Because it's trained on a digital factory of synthetic data. Multilingual text, GeoGebra diagrams, sarcasm-laden memes, 3D spatial reasoning tasks. And the proof? On TextEdit, a new benchmark with 2,148 real-world editing scenarios. It matches the top closed-source model, despite being open source and smaller. This isn't just a win on paper, it's a democratization of AI. Free, fast, accessible. The future isn't about size. It's about architecture. And InternVL-U proves that small, smart models can beat giants if they're built right. #4. ConStory-Bench, the AI storytelling audit that exposes consistency bugs. AI can now write 10,000-word novels. But here's the catch, they often forget their own story. A character says they'll never return to the city, then walks back in without explanation. A mountain is in the north, then suddenly in the south. These aren't typos. They're consistency bugs, and they're rampant. To fix this, researchers from Microsoft and SUTD created ConStory-Bench, a benchmark that measures narrative consistency, not just fluency. It uses ConStory checker, an automated pipeline that 1. Scans the story across 5 dimensions, timeline, character, world-building, facts, style. 2. Pairs conflicting statements. 3. Builds evidence chains, showing where, why, and how the contradiction breaks. The results? The best model, GPT-5 reasoning, still has 113 errors per 10,000 words, nearly 1 every 87 words. But here's what's really revealing. Errors cluster in the middle of stories where working memory degrades. And entropy spikes before errors occur, meaning the model is hesitating. This isn't just about fixing bugs. It's about trust. If AI writes books, screenplays, or technical docs, it must stay true to its own world. The solution? Early warning systems. Detect high entropy. Trigger self-checks. And use models like Longwriter Zero that use reflection loops. The future of long-form AI isn't just about length, it's about consistency. And ConStory-Bench gives us the tools to measure it and fix it. #5. Mario, the graph reasoner that knows when to listen to text or image. On e-commerce, a product isn't just an image and a title, it's a node in a web of meaning. But most models treat image and text as isolated pairs, ignoring the structure. Enter Mario, a 2-stage framework for multimodal graph reasoning. Stage 1, Graph Condition Vision Language Model, GVLM. It doesn't align image and text in isolation. Instead, it uses the graph structure as a guide, injecting structural context like shortest path distance and node centrality into attention. This ensures image and text are coherent in context, not just semantically close, but logically consistent. Stage 2, Modality Adaptive Prompt Router, MAPR. Not every node wants the same modality. A text-rich product needs text. A noisy image with a bold logo needs image. Mario's router learns which modality works best by watching the LLM's performance. It routes each node to the optimal prompt, text-only, image-only, or multimodal, and only runs one. Results? Up to 7% higher accuracy on Amazon and Reddit benchmarks. On zero-shot transfer 6 times better. On Toys Right Arrow Movies. 41% accuracy versus 24.95% for the best baseline. And the router learns homophily. Similar products prefer similar modalities. It's not guessing. It's understanding. Mario isn't just a model. It's a new foundation, where LLMs don't just follow prompts, they reason with context, resolve ambiguity, and adapt to the data. So what's the overarching insight this week? AI is no longer just about scale, it's about structure. LowGR uses hybrid memory to anchor long contexts. ProRes uses staged learning to stabilize deep models. InternVL-U uses decoupled reasoning to think before creating. ConStory-Bench uses automated auditing to ensure consistency. Mario uses graph structure to guide multimodal reasoning. The future isn't just bigger models. It's smarter architectures, coordinated learning, and intelligent systems that understand context, remember their world, and reason like humans. And the best part? Many of these breakthroughs are open source, efficient, and accessible. So if you're building, researching, or just geeking out on AI, check out the papers, try the models, and join the movement. Backend index pointing right LowGR project, GitHub. Backend index pointing right ProRes, archive link in description. Backend index pointing right InternVL-U, github.com/OpenGVLab/InternVL-U. Backend index pointing right ConStory-Bench, archive link. Backend index pointing right Mario, archive link. Like this video, subscribe, hit the bell, and let's keep building the future, one intelligent system at a time.